systems. But with that, I want to move to a different kind of acoustic vulnerability for IoT systems, and that is ultrasound. So let me switch my presentation here. OK, this is some relatively recent work by some colleagues of mine from Zhejiang University out in China. And they won this great paper award for it. But basically, they showed how to use ultrasound, inaudible tones, to fool voice recognition assistants into basically doing whatever you want it to do. So I don't know, has anyone here used a voice recognition assistant ever? Like a Siri or an OK Google or an Echo? Oh, OK, most of you. So that's what we're talking about. It turns out those systems have superhuman hearing. Humans can only hear up to about 20 kilohertz. Unless you're a reptile, you can hear a lot more. I don't think we have too many reptiles registered this semester. But phones and microphones can hear well above 20 kilohertz. And so if an adversary can inject ultrasound, they can control your voice assistant, is basically the thesis here. And we're talking about everything from Apple's Siri to Google's stuff. All of these systems have microphones. And just like we talked about radio waves are one thing, but what about sound waves? And we can use sound waves to accomplish the same feat, but inaudibly. So how do these systems work today? Again, a lot of this is about just defending against interference. So your voice goes into a microphone that's turned into electrical waves. You've got a speech recognition software program, and that causes the command and control of anything from your automobile to your at-home Amazon Echo or whatever. Let's see. I'm going to try to finish this up in a few minutes with a survey. But suffice to say, you can inject all sorts of stuff to fool systems into. This is from the student in China, so he's got a weird sense of humor. But you can fool all these Amazon Echoes into saying false sensations. So what we're going to do in a few minutes is a little demonstration. You can actually do this at home if you want with a really low-cost speaker for about $3. But in class today, we're going to show how to use a high-powered beam-forming acoustic array. And we're going to do a live demo. And so Xinjiang is a visiting PhD student in my laboratory. And she spent the last few weeks building some of these systems. And we're going to look for some volunteers. And so actually, do we have any volunteers who happen to have an iPhone X who have the ability to record sound and play it back on the speakerphone? OK, so anyone with an iPhone X who wants to be part of an experiment, we promise to probably not damage your phone. You can come up to the front, and you can participate in this little experiment. We're going to have you record some inaudible sounds, and we're going to see how this works for real. OK, so I know the people in the back can't quite see it, but what we've got is an array of 20. Where'd the other little sensor go? Oh, it's in your bag. We've got an array of 20 ultrasonic transducers. These are emitters that send out inaudible tones. And they're very directional. They form, They form these little tiny beams of sound. And it's ultrasonic, so you can't hear it. Is it playing at the moment?
Yes.
No. OK. Why don't we start playing it? We'll see if it's. You shouldn't be able to. Do you hear anything? I don't. Do you hear anything? No. OK. Well, what we're going to do is we're going to have you turn on your voice recording and then play it back. So I'm going to be really quiet. And we're going to take a recording and then play it back.
How close do I have to get? Around you? You should put the microphone directly to this.
OK, I think that's good enough. Now, did anyone hear anything? OK, why don't we play back? What did your microphone hear? If you have speaker too. Yeah. So nobody do this cheating on the exam, by the way. We'll find you. because you can speak with like pencil point granularity. But let me just show you about the other things you can do with ultrasound. Again, this is all, and I'll show you in a few minutes about how these systems actually work. But if we play the, oh, it is? So does anyone hear anything yet? OK, I'm going to put my microphone into the ultrasonic beam. Now, I don't know where it is, so I have to search for the beam. But let's see if we can find it. OK. So my dream is that one of you someday does a little project where we send a Trojan gift to like the Ohio State coach, and he puts it next to his phone in his office, and then whenever he makes a radio interview, you hear the fight song in the background. So if you're interested in that, give me a call. But that's the basic idea of how you can use ultrasound to inject inaudible commands. But I'll just say a lot of the threat models here become pretty obvious pretty quick. So for instance, if you're talking to